Hi, my name is Evan Lowe at Mechanical Simulation, and in this video I will be reviewing how to use CarSim to simulate Euro NCAP Adaptive Cruise Control performance tests. First, I'll discuss a brief background regarding the Euro NCAP ACC tests, show how to run the tests in CarSim, and get into just a few details of the simulation example setup. Euro NCAP stands for European New Car Assessment Program, and the Adaptive Cruise Control, or ACC tests, utilize 3 Euro NCAP test protocol specifications. The first of which is the AEB Car-to-Car Systems test protocol. Another test protocol that was newly created in 2020 is called the Assisted Driving Highway Assist Systems Test and Assessment Protocol, which includes test specifications for advanced driver assistance systems, one of which is ACC Performance. The last specification that is useful for ACC performance tests is that of the Global Vehicle Target, and we will discuss more about the GVT later on. There are several Euro NCAP ACC examples included for the first time in CarSim 2021.1 that relate to the AEB test protocol and are called car-to-car rear tests, denoted by the acronym CCR. Further test specification denotes whether the test target, also known as the Global Vehicle Target, or GVT, is moving in front of the ego vehicle at a constant speed, CCRM for motion, is stationary, CCRS, or is moving at a constant speed and then brakes, CCRB. The entire list of the Euro NCAP ACC tests can be seen here in this summary from the Assisted Driving Highway Assist Systems Test and Assessment Protocol. In this list you also see VUT, which stands for Vehicle Under Test, or the ego vehicle, and GVT, which is the Global Vehicle Target that we mentioned before. Here are a few more details about the VUT and GVT. To access the Euro NCAP ACC examples in CarSim, the user can navigate to the Datasets menu and search for the ACC Euro NCAP Tests category. Then, by unlocking the example of choice, the user can run the math model and review the results. By clicking Video plus Plot on the Run Control screen, the user can see both the output animation of the Euro NCAP ACC test that was just run, in addition to several output plots, 2 of which are the scoring and the longitudinal acceleration. Several other key pieces of information are output to the VS Visualizer's heads-up display, such as time to collision, relative distance, relative speed, and even scoring for the run. Going back to the Euro NCAP ACC test category of datasets, we can see all of the various examples that represent those written in the ACC test protocol document. The CCRB tests include 1 run per example, whereas the CCRM and CCRS tests have multiple runs in each example. This was coordinated with VS events and can be seen in the visualizer when the VUT restarts at its initial position after completing 1 run of the test. Tests titled Cut In and Cut Out are also included in the Euro NCAP ACC performance tests and simulated in CarSim. The cut in involves a GVT in a lane adjacent to the VUT, cutting in front of the VUT with a specified trajectory, speed, and timing compared to that of the VUT's travel. The VUT must then avoid hitting the GVT by utilizing its ACC controls. Similarly, cut-out examples include the VUT and a human-driven vehicle traveling in front of the VUT and in its lane, occluding vision to a stopped GVT ahead. The human-driven vehicle leaves the lane at a particular time to collision with the stationary GVT ahead, and while leaving the lane, reveals the GVT to the VUT. At this point, the VUT must avoid colliding with the GVT by utilizing its ACC controls. Lastly, There are two more general examples provided in CarSim that are not part of the Euro NCAP ACC Performance tests, but can be useful when developing ACC logic. These tests are the slow down and slow to stop ACC tests. In the slowdown test, the VUT with ACC must detect the vehicle in its lane traveling at a slower speed, and the VUT must slow down to meet the speed of the vehicle ahead. Additionally, a parked car is placed on the side of the road to assure that the ACC perception logic does not detect false positives. The slow to stop test requires that the VUT detect a vehicle in its lane that is stopped, and the VUT must come to a complete stop to avoid hitting the vehicle ahead. The goal with these two examples is that if the VUT ACC logic can perform well in these tests, they should have good prospects for the Euro NCAP ACC Performance tests as well. A few final notes are that the ACC logic for these examples are found within the vehicle dataset and also within the ACC and AEB, or Autonomous Emergency Braking, logic dataset. AEB and FCW, or Forward Collision Warning, logic are found within the vehicle dataset as well. AEB is not active during these Euro NCAP ACC examples, but the user can activate it with an update to one parameter value if they would like to test ACC and AEB simultaneously. Additionally, the CarSim Lane Keeping Assist provides the steering control for these examples rather than the driver model. This is stipulated in the Euro NCAP ACC test protocols. If the VUT has lane assist capabilities, it should be turned on during the ACC tests. This is also why you may see the lane detection markers in the ACC example animations. This concludes our overview of how to use CarSim to simulate Euro NCAP ACC performance tests. Also, if you'd like to learn more about CarSim Euro NCAP tests, check out the link to our AEB VRU video in the description below, along with other CarSim ADAS video links. Thank you for watching, and please like this video if you enjoyed the content, and subscribe to our channel for even more CarSim, TruckSim, and BikeSim content just like this. And don't forget to check out the mechanical simulation website at carsim.com.